Let's start our today's training. Last time I introduced eGear function, and today I will introduce the Ecam function, how to configure the Ecam table and some related function block. And also I will use one case project to show how it works. First part, uh, this is the define of, sorry, I didn't change here. This is the define of Ecam. Here in this picture, it is machine code cam. Machine code cam is we will have one master axis and one slave axis. We can see the motion. The motion of the slave axis is depends on the rotation of the master axis. So this is the machine code cam. And what's the electric can? Electric can is we use PLC to create the position relationship between the master and the slave, something like this, to simulate the motion of the machine code cams. So this is the electric cam. Some advantage. First, it's easily to design the uh, Ecam curve rather than design the machine code cam. And the second, we can change our Ecam curve, or we can set different Ecam curve in one project and switch between them. So and also it's more economic to use the Ecam rather than this machine code cam. And this picture is the Ecam curve. Ecam curve in Wecon. Here is the relationship between the master position and the slave position. This is master position and slave velocity, and also master position and slave acceleration, slave jack. In the table, we just need to set the key points, master position, slave position, and the curve type between two points. And these three curve will be generated automatically. Some application about Ecam, rotary cutting and flying cutting. Okay, now let's check how to create the Ecam. First, in today's project, I also use this CFC language, and we add two virtual axes, one as the master and another one as the slave. And next part, to create Ecam cable. This is the steps to add the virtual axis. Right click this soft motion, generate axis pool, and you can rename the axis name here. Okay, and the next, to create the Ecam table, we can right click application, add object, and this Ecam table. And after creating Ecam table, we can configure the properties of this cam table. This is the mainly setting we need to set for our cam table. In these properties, you can see this cam selection, and here have some setting about our Ecam. First is this one. It's the table size of the master and the slave axis. Default is between 0 to 360. And also you can set the a period of the sleep axis and some other setting. Usually this setting we keep default. And also the last is compiled fault. We also default is this one. It means the different way of our PLC to touch the cam curve. And this continuity requirements is used for some cyclic cam curve because between last cycle and last cycle and the next cycle, the movement of the slave may need to how to say need to span smoothly, and this is the settings about the connecting between two Ecam cycle. And also here this is our Ecam table. Here you can click this to add point or click this to delete the point. And between 2 points, you can set the curve type. We have 3 selection. This is master position, and Y is the slave position. V is slave velocity, and slave acceleration, slave check. Like this. Okay. And now I will introduce some related function block in Ecam. First one is this MC cam table select. This function block is used to bind the master and the slave axis to our cam table. Some master axis, slave axis, you can use this axis name directly. So here I directly name the master as master, slave as the slave. And this is our cam table name. And I use default name cam. And this periodic, this is if we set it as true, it means it's a cyclic cam table. And master absolute and slave absolute. These two parameter is used to set the running mode of our master and slave. When we set it as true, it means it's absolute coordinates. The zero position of the cam table will be correspond to the zero position of the master and the slave. So, and if you set it as false, its relative coordinates and the zero position of the cam table is correspond to the current position of the master or slave. And these two parameters will work together with this start mode. And I will introduce how they work together later. Okay, and then for the output, here we have one cam table ID. This output we need to use it as the input parameter of this MC cam in function block. You can see here have cam table ID. So you can directly connect them like this. Here, cam table select output as the input of this cam in. And this cam in is used to trigger the Ecam running. master slave is set, and for this here we have the master slave offset and scaling. This offset and scaling is used to calculate uh, how to say to set the game and offset of our master position and X select position. For example, in this scan table, we can see normally when the master achieve 450, select should be achieve 130. But if you set the, for example, you set the slave offset as 100, it means when the master achieve 450, the slave will achieve 230. But normally we can set the offset as 0 and set the scaling as 1. And also in today's project, I set this parameter. Master start distance and master sync position. These two parameters we have introduced it in e-gear imports function block, if you remember, in our last training. And then the usage and then the define of these two parameters is then first master start distance. When the master position achieve master sync position reduce master distance. This left will start syncing, and when the master achieve the master sync position, slave should be here. Slave should be enter in sync status. For example, in this table, if you set the master start distance as 100 and master sync position as 400, it means 400 reduce 100 is 300. It means when the master achieve 300, the slave will begin to move. And when the master achieve 400, the slave will achieve this point. Sorry, not this. 400 here. When the master achieve 400, master sync position, slave will catch up to this maybe about 80, and from this point, the master and the slave will follow this cam curve to move. And the start mode, I've introduced this later, and the cam table ID have introduced it. Before we can first check this another function block MC cam out. It's similar to MC GL out. After we trigger this function block, it's left where alt where alternate sync status and keep the current position to running. And if you want to stop it, you can use MC stop to stop it. Why it's called virtual axis? Because we are use virtual axis, it's not real axis. When you connect real axis, for something like servo driver and motor, then you need to insert you need to add device here. Add device is a catch. soft motion, and under this soft motion master, you add your servo driver and add the axis. This is not real axis, these two. It simulates simulation by PLC. Can we have the project fails after? Yes. We can continue the training first. Okay. And some other function block. I have introduced this before, so we can skip this. And here, this table showing how this start mode and select absolute work together. Here the select running mode depend on these two parameter, and this table is the relationship between these three parameter. When you set the cam in start mode as absolute and set the MC cam table select absolute as true, then the running state of the select will be absolute. And also, for example, if you set the start mode as relative and set the select absolute as false, then the running status of select will be relative. So what about the running master running mode? The master running mode is only depend on this parameter. Depend on this master absolute, this parameter in MC cam table select. And now I will introduce here when the master running mode and the different master running mode and select running mode will how the movement be like. This is the Ecam table. Ecam table I used is very simple. When the master move from 0 to 180, this left will move from 0 to it's about 460. And when the master go from 180 to 360, this left will go from 360 to 0. So this is the Ecam table. And now, when the running mode and the only mode of master and slave are both absolute, it means when copying, when copying. The master position, for example, the master position is X, and in the table, in the cam table, the response position of the slave should be Y. And at this moment, if we trigger the cam in, if the slave position is different with Y position, the slave position will jump to Y. It's very dangerous. In this picture, you can see this signal. This signal is a start signal of the cam in, and this blue and green color is master and slave position. Here, when I trigger the cam in, the master position is 0, and in this table, slave position is also 0. It means Y is 0. And also my current position of Y of slave is also 0. So there will be no axis jumping. So it's work normally. But here you can see this is green. Green color is the master position. You can see the start position of the master is not 0. is maybe about 100. So in the page in the pic in this cam table, 100 is when x is 100, the y should be about 200. But when I trigger the cam in, the position of slave is 0. So you can see here the blue the blue color. The position of the slave is jump from 0 to this 200 directly. So it will cause it's dangerous. So when you use absolute modes, please make sure the position of the slave is in correct position. Otherwise, it may damage your machine. It's very dangerous. And if the master running mode is absolute and the slave running mode is relative, when you trigger the MC came in, master position X, and also in the table slave position should be Y. Here, if Y is not 0, the slave position will also jump to Y position, like this. So it's also dangerous. And for this, if the master is relative mode and the slave is absolute mode, when you trigger the MC came in, if the slave current position is not 0, the slave position will jump to 0. This is normal status, no jump. But here, in this picture, you can see the initial position of the slave is not 0. It's maybe 100 or 200. And at this point, when you trigger MC came in, the slave position will jump to 0 from here to here, and wait for master to move and the slave to follow. So in this situation, the slave will also jump if the position is not correct. It's also dangerous. Okay, but uh, okay. And if the master and the slave are running in relative modes, there will be no jumping. How to understand? You can see in this picture, the initial position of the master is about maybe 30, and the initial position of the slave is 100. And at this point, I trigger the MC came in. You can see the master and slave will keep its current position. And in this position, when the master begin to move, slave will also begin to move, following this cam table, and there will be no jump of the slave. So in this condition, it's safe. So you can see whenever Whenever the master is absolute mode or slave is absolute mode or bonds are absolute mode, they will have some uh, they will have some dangers about the slave to jump if the position configuration is not correct. Uh, how to add pose? If you want to add pose axis, first your PLC should support local high-speed I/O. Only new 6C or AC60 supports high-speed I/O. You can add here. Uh, you in this local high-speed I/O. Double click and here you can select the post axis, this one, this axis, and you can use this axis name to the cam in or cam select function block. Okay. uh, oh, and here also, when the master is absolute mode and the slave is ramp in absolute. You can here when you set the start mode as this ramp in, and you will have the slave running mode, ramp in absolute or ramp in relative. So here, in this condition, when we trigger the MC came in, and also the master position is X, which the slave position should be in on the CAN table should be Y. And if the slave position is not is different with Y, the slave will begin to catch up with the point Y, with the setting acceleration, deceleration, and velocity difference. So you can see in this picture, in this point, when I trigger came in, the slave will begin to speed up to catch this Y position like this. So the difference between this mode and the first mode is slave will not directly jump to Y position. It will speed up to catch Y position as soon as possible with the setting parameter. And also in this moment, the master maybe also begin to move, which in this moment during the catching segment, if the master position is uh, changing, we will see this Y parameter will also changing. So it means the target position of the slave will also changing. So anyway, the slave will try it is best to catch the Y. And once the slave achieve Y position, the master and the slave will enter in sync status and follow the cam table to running. So they will have one question. If you set this catch up parameter too small, it means the master will have no will not cannot to catch uh, the master position. And also they have some other different uh, combine of the master position and the slave positions too much. So here I only show these five conditions. Okay, now let's check our check our demo project. Uh, this part is used to enable axis, read position, read velocity of an axis. Also, MC stop, home, and reset. And here we have cam in, cam table select, cam out, and then MC job function of our master and slave. And also I use this MC move velocity to make our master to launch continually. And also I created one, this one, visualization to show it. First, here we enable these two axes. Enable master and slave. Okay. And now we first run this MC cam table select. And this is the cam table. Where's my here? This is the cam table. Here have 1, 2, 3, 4, 5 segments. And the first segment, when the master running, slave will stop here. And the second segment, the slave will begin to speed up. In segment 3, the slave and the master will have the same speed. And later, the slave begin to slow down and last stop. So this curve is a little like this application. This application. This master is continue running and the slave stop and speed up, cutting and slow down and stop. And when cutting, the line speed of the master and the slave should be same. How to create a cam curve? You can here I can create a new one. Cam table. And this is the default cable. Here you can change you can add points and set the different segment type between 2 points. So we just need to set the key point and the curve between 2 points will generate by PLC directly. This is, for example, here, between these 2 points, I set this segment type as line. So this part is a line segment. But here, from the between last 2 points, the segment type is poly 5. So you can see the curve will be like this. Also you can write the cam table data to your PC, and also you can import the cam table from your PC. Here have import and output function, and also you can move the position here by your mouse. And these 3 parts, these 3 curve will be generated by PLC. So you only need to set the key point. And mhm. Okay, we can first check this demo. And now here I set bounce master and slave as absolute modes and set the start mode as ramp in with this parameter. And the trigger came in. Now we move the master with this uh, move velocity function block. Okay, and here we stop the master. For example, we jump the master because now the master and the slave is still in sync status. So they are so the slave is still move according to the master position. And here, if we came out the slave, you can see the slave will keep its speed to running. And we use MC stop to stop bounce master and slave. And we run this MC came in again. You will see after we trigger this function block, the slave will will directly to move to this position. Why to move? Why it will move to this position? Because when the master in this position in the cam table, the slave should be in this place. So it will directly adjust the current position to here. And then now if we run the master again, the slave will continue to throw in the master to rotate. Which application? How to identify can type? It's the cam curve is depend on your application. So it means you need to know the position relationship between your master and slave during one cycle. So and then you can design your cam table. So you should have the application first, and you know the position relationship between the master and the slave, and you begin to design the cam table and run the cam table. Okay, and this is our today's mainly content, and this Tuesday I will introduce axis group function and in the center. So welcome to join the training the day after tomorrow. The day after tomorrow. And thanks for your attending. Now, if you have any questions, you can type here.